going to share how Polo explained to me the way he analyzed this pickup. As you know, this is in the box folder. Links is in the video description of all my videos. Now, we start by looking at indication of an actual exploitation, not just an attack, but an exploitation. We can take this AQL. The payload to hex is an AQL function. It comes in many Curator packages, like the EDR one, etc. And we're looking for this magic word, the CAFE-BABE, copy baby, which indicates that a Java class is being served, and we want to see if that has happened from a remote location, which should not be the case. So let's go into the advanced search and paste that, and let me make that, because I replayed that pickup yesterday. Let me do about 40 hours. And click search. And that is not as fast as the quick filter that took milliseconds, but this takes a couple of seconds, going back 40 hours looking for that needle in the haystack, and it finds it in 9 seconds. That's pretty good. We can look at this, any one of these flows, and this is just plain QNI. That silly message there. And let's start by looking at the IP addresses. So this IP address is our server. We recognize this address as a local address of one of our servers. Okay. You can go into the asset database to get more details of it, but this you recognize as your own, should be in the network topology as your own, as an internal IP address. This one you don't. This 11 one, I do not know what that is. That's an external IP address. Again, the guy who modified the pickup put internal addresses for this thing to work nicely, but in your case will be an external one. And what you see, it's a get, and you get a post here. Let me actually switch here to the standard UTF, right? And then this is being served, and it's actually requesting a Java class, and this is the way it looks. We can actually see that this is a whole bunch of Java things. So this is an external address, so this raises all kind of flags. And in fact, if we go here to the hex, we can see here the CAFE-BABA, right? That's what the search was starting. So let's actually go to the whiteboard and start making sense of all these. So we have this 172.16.238.10. That's our server. And we know that it's vulnerable. Okay, and it's actually communicating. There is a request and a response for a Java class. And we know that that is bad. So this particular server is malicious, is serving Java classes that are good for the exploit. Okay, Java class. Now, what else can we learn here? Let's try to understand a little bit more about the attack. Because what we found here is the actual attack, but we want to see everything that happens before, and we are trying to make sense out of all these. So let's actually switch to quick filter, and here we're going to look, as we shown in the previous videos, for anything that begins with JNDI, because remember this is an attack in which the lookup service that JNDI provides is actually being used with LDAP, RMI, and any other services. Now we need to go back in time. Let me actually go 24 hours. Let me expand this, because this I played it in the morning. So let me go, instead of 6 p.m., let me actually go 5 a.m. Click update. And here we have two more entries. Let me expand here the destination IP. No, so okay, this one I can ignore because I know these are my Curator boxes, but this one is kind of interesting. That 16.238.1, again, in your case, will be an external IP address. This is one that we don't know. Notice the port is 8080, and it's talking to our server. So let's actually go back to the whiteboard and put this one in there. This is 172.16.238.1. That's an external IP address as well that is talking to our server. Let's see what is actually going on between those two. If we expand and look at the details of this flow, what is it that we see? We see the addresses, we see the ports, 1984, 8080, and we see that it's actually okay. So notice that again, we found, as we showed in the previous videos, that if you have in the user agent field GNDI, that's the source of the Log4j vulnerability. It didn't sanitize the field. You should never have in the user agent a GNDI request, but if you do, it's actually going to be served on this machine 11 that we saw before. Remember, this is where the Java was served. So it's actually the lookup is making a look and say, we'll go and search in via LDAP for on this particular directory. The directory is /a, and the port is 1339. So 389 is LDAP, 1339 is used here for JNDI. It doesn't have to be that port, but that seems to be the initial case. So that is one vector that is doing the attack. There's another vector in here. This uname as username, and a password is actually being sent, and this is being encoded. This looks like URL encoding. Let's actually go to URL to a page to do the decoding and put that and do the decoding. Notice that again we see JNDI LDAP in there. This is probably done as a means of obfuscation to avoid detection. Why do they use two attacks? Well, because maybe somebody is blocking that field uname with anything encoded in there, or but so, and they can be more than one vector. Let's see what works. Remember, the bad guys are really doing this massively before people patch their systems. At this point, perhaps the best thing to do, again, this is Curator, we don't care about this is our vulnerable server. The best thing for us to do will probably be to show anything where this is the source of destination. So we use that filter very quickly in there. On that time, we clear the JNDI. We want to see everything that our vulnerable server did. And here are all the things. Let's actually sort them chronologically. So let me sort them in the reverse order. Yeah, from 11:30:35 to 11:30:54. So this happens very quickly at the replay of the pickup. Let's analyze these things. So we see the communication between the address that ends in 1 and our vulnerable server. We see 3 of those in here. And but the reason why these are 0 and 0, these are the QNI normalized fields, right? But we actually already analyzed this one, so we can actually go back to the whiteboard, and chronologically we know that this was the attacker. Okay, so the thing started here. Let's look at this. That gives us the detail. This is between, remember, that's the one where we first detected this, the one on 11 one, right? Let's scroll down and see the actual payload. This is in the indication of, it looks like it's giving the instruction on the machine, go and look at my vulnerable server, go to this very same machine on 11, but now on port 80, and look for a particular class, and that's the class that is actually going to be loaded for the exploitation. If we look here, right after that, we see that our machine actually did that. It went on port 80. Let's actually see what happened there. Okay, and we see that it actually loaded that Java class, and this is what actually gave us the indication. Notice the cafe baby there. Okay, and that's the field that we saw at the beginning, and that's how we detected that something bad happened. Let's see what else can we make sense out of this. There is another one, and when we see that source and destination packet 0, that's the QNI normalized fields that we see here, right? We see the hashes and all that stuff. Those are IP fixes that QNI provide us. So that's actually good. Let's see what else do we see chronologically going down. Well, this player we haven't seen so far. 10.10.10.31, and it's a significant amount of bytes being actually transmitted there. Let's actually go to the whiteboard and incorporate this guy. This is 10.10.10.31. So we need to assume that the server executed the Java class that from this. Let me actually clean this graph a bit. So let's actually look at the details of this new player 10.10.31 and see what happened there. Actually, a lot of things happen. So notice that this is actually by running that class on the vulnerable server, it actually went out and executed these commands on the destination payload: id, print working directory, sudo cat etc shadow, so that's to get the password, and then exit it. Let me actually scroll down to see. Notice that the ID is 1000 user. Here's the sudo. The print working directory is home user. Now we are root. And no, actually, this is the content of the etc shadow. These are all the credentials in here, right? And we can even see a good hash there for that particular user. So that's the actual exfiltration phase of the attack. So that allows us to put all the actors and all what happened here. We can even see that there is more communication after that from our vulnerable server to that malicious server that served the class, and yet another communication to that entity for the exfiltration. But it looks like the big exfiltration of data actually happening here. Notice the source and destination byte count. So I hope that this gives you an idea of how to use not only Curator for detecting the attack, but how to reconstruct the different aspect of it. Thank you, Paulo, for putting all this together.